All right, this is Unit 1, Lesson 13. We're talking about more standard deviation. We're going to do 13.1 and 13.3 on this lesson. We're going to skip the 13.2 card sort. So 13.1, it says evaluate mentally. So that means no calculators, no pencil paper, just evaluate it, and then you can write down what you got. So take about 5 minutes or however long it takes you to evaluate each of these mentally. So pause it and do the warm-up 13.1, all 4 of these right here, and then you can unpause whenever you are finished evaluating those. Okay, so on the first one, it's 0.5 times 30. So if you might have said, this is half of 30. That's kind of what I thought about whenever I looked at it. So half of 30 equals 15. On this next one, it's 1.5 equals 30. So depending on your strategy, you might have thought, that really doesn't look like it's lined up. Let me just make a new text box. You might have said, okay, well, 1 times 30 is 30. A half times 30 is 15. So 1.5 times 30 is going to give me 45. Is what you should have gotten for that one. On the next one, you have 100 minus 1.5 times 30. So that means you already know that 1.5 times 30 is 45. So 100 minus that, you should get that it equals 55. And the last one, you have 100 minus 1.5 times 18. So looking at 1.5 times 18 first, 1 times 18 is 18. Half of 18 is 9. So 18 plus 9, that gives you 27. And then you have to do 100 minus that. So you should have gotten that it is 73. So you just have to think about strategies that you can do to answer those. So over here to the right, just create a new text box and tell me what did you do to calculate those. All right, so 13.2, we're going to skip this partner activity for now, and we're going to look at 13.3. And it's interpreting measures of center and variability. So for each situation, you are given 2 graphs of data, a measure of center for each, and a measure of variability for each. So it says interpret the measure of center in terms of the situation. So real quick, I want to just kind of quickly review. Measures of center are mean or median. I'm going to just put and median. These are both measures of center. Measures of variability it's going to be your standard deviation and IQR, which is interquartile range. I'll just leave it like that because I don't really have room to type that. So those are your two measures of center. These are your two measures of variability. Then I want you to compare the two data sets. So look at number 1. The heights of the 40 trees in each of two forests are collected. So here's the two forests. We have a mean of 44.8, standard deviation of 4.72 feet, a mean of 56.03, and a standard deviation of 7.87. So they want you to interpret the measure of center in terms of the situation, interpret the measure of variability in terms of the situation, compare the two data sets. So for number 1, we're looking at these, and the mean is what they gave us here. It tells us the average height of the trees in each forest. Some will be taller and some will be shorter, but it tells us that 44.8 feet is the average and 56.03 feet is the average for this one. Let me see where we just have to write it underneath it. We'll just make a text box and put it under here. So on A, the mean tells us the average height of the trees, or of trees, in each forest. Some will be taller and some shorter. That's it. On B, the standard deviation for each of these tells us it's a measure of how variable the tree heights are. So a larger value means there are much taller and much shorter trees than the average. A smaller value is going to mean that they are mostly the same height. So for this situation, the standard deviation is a measure of how variable the tree heights are. A larger value means there are much taller and much shorter trees than the average. A smaller value means they are mostly the same height. So I like to tell students that like a larger variability means they're less consistent, like they're not as consistent to the mean. And a smaller variability, so a smaller standard deviation, means they're more consistent. So like here, a smaller value means they are mostly the same height as the mean. We can add that. Mostly the same height as the average. So they're more consistent with the average. A smaller standard deviation means the heights are more consistent with the average. All right, so C says, this is where we compare them. So we're looking at the two data sets and we are comparing those. So the trees in forest B tend to be taller based on the mean, because look at your mean. You've got 56.03. So 56.03, and then you've got 44.8. So the trees in forest B tend to be taller based on the mean. But now look at the standard deviations. What do you notice about those? This one's 4.72 feet. This one's 7.87. So this standard deviation of 7.87 feet tells me they're less consistent with the mean. You've got taller and shorter trees. They're not as close to the height of the mean. So let's see, but they are, also more variable. So they have more variation going on here. So trees, let's do trees in forest A will be a little more uniform than in forest B. So the ones in forest A are going to be closer to the height of the mean. And you can see, look at how these trees are all closer to the center. They're closer to that mean. And look at these and how they are all, they're more spread out. So the more spread out they are, the larger your standard deviation is going to be. So I hope this is helping you be able to see what the mean is talking about, which is the measure of center, and then the standard deviation, which is how spread out the data is from the mean. Again, if I'm going too fast, always feel free to pause so that you can catch up. Okay, number 2, we have the number of minutes it takes Lynn and Noah to finish their test in German class is collected for the year. So they've given us the mean, standard deviation for each of these. So remember, we are going to interpret the measure of center in terms of the situation, interpret the measure of variability in terms of the situation, and we're then going to compare the two data sets. Okay, so let me get back to my text box. All right, so A. A is where we are interpreting the measure of center, and they gave us the mean. So the mean is 29.48 and 28.44. So the mean tells us the average number of minutes it takes each person to finish the test for German. Okay, so that's the average time it takes to finish their test. Each test, because you have like, this is each test that they took, 20 minutes, 22 minutes, 24 minutes, and so on. All right, let's look at B. That's where we're talking about the standard deviation. So the standard deviation for this one was 5.44 minutes. Standard deviation for this one is 7.40 minutes. So Lynn, the times were closer to the center. And Noah, you can see how spread out the data is. All right, so let's put something down for this one. The standard deviation represents how variable the times are. A greater value means sometimes the person finishes much slower or faster than the mean. A smaller value means the person finishes around the same time for each test. So looking at this, Lynn finished around the same time for each test. Now she did have one that was 20 minutes and one that was 40 minutes, but that's only, 11 minutes longer than the mean, and then that one's only 9 minutes shorter than her mean time. And looking at Noah's, we've got all the way down to, looks like, close to 15 minutes, and then all the way up to 42 minutes, but the mean was 28.44. So you can see there's a wider variety. The data is more variable. It's more spread out. Okay. C. So comparing the two data sets, we know on average, look at their average, our mean, Noah's is lower. So on average, He finishes quicker. But he can't go on that same amount every time because he had a test where it took him 42 minutes and 41 minutes and 36 minutes. And then he had a test where it took him right at 15 minutes. But Lynn, she finishes 29.48 minutes as her average, but she's pretty close to that same time every time she takes the test in that class. So Noah is faster. To finish the test on average, but Lynn is more consistent in her finishing times. Okay, again, you can pause if you need to. I'm going to go on to number 3. The number of raisins in a cereal with a name brand and the generic version of the same cereal are collected for several boxes. So for these, we have our mean, it's 289.1 raisins. Our standard deviation is 19.8 raisins. That's for the name brand cereal. For the generic cereal, there's 249.17 raisins and a standard deviation of 26.35. So looking at those, the mean is higher on the brand cereal and it has a lower standard deviation, so it's more consistent. The mean on the generic is lower and it's not very consistent. With it having a higher standard deviation means it's less consistent than the brand cereal. So let's put some text down for this one. So we have A, our mean for each of these, it tells us the average number of raisins in a box of cereal. Okay, so the mean tells us the average number of raisins in a box of cereal. That's it. What does the standard deviation tell us? The standard deviation shows how variable the number of raisins are. The standard deviation shows how variable the number of raisins are. A smaller value, what does the smaller value tell us? Means the boxes of that type of cereal tend to be more consistent with the number of raisins in the box. A larger value means there is more variety, so they're less consistent. So there's more variety in different boxes of the same type of cereal. So we can say for the generic ones, they're less consistent on how many raisins there are. The mean overall is lower, and the data is spread out, so you have no idea how many raisins you're probably going to get in the generic box. All right, so let's compare these two data sets. The name brand cereal. What did we see about the name brand cereal? We see that the mean is higher, so there's more raisins typically, and they're more consistent. So the name brand cereal has more raisins on average and is more consistent with the number of raisins in a box. The generic cereal tends to have fewer raisins, but is also less consistent with the number of raisins in a box. All right, again, pause if you need to on that. Before we go to the lesson summary, let's talk about some things. Let me see if I have some room to type some things. We'll type it down here. Actually, we're going to type it under the lesson summary. Just some questions and answers just to discuss with you a little bit. So, what information does standard deviation tell you about a data set? Let's change to let's do that and add another text box here so you can see the questions and answers. Okay, so standard deviation, well, I want to change to black now. It tells you how variable the data is relative to the mean. So you have your mean, and then if your standard deviation is low, then it tells you all the rest of the data is close to the mean. If your standard deviation is high, a larger number, then it tells you the data is spread out quite a ways away from the mean, that it's just scattered everywhere. All right, so let's go over here. Let's look at another question. Two professional race car drivers have the same average lap times after 50 laps. What does it mean to say that the first driver's lap times have a greater standard deviation than the second driver's lap times? I'll put the answer. I don't know if I can move it. It'll let me move it right there. Okay, so what does it mean to say that the first driver's lap times have a greater standard deviation than the second driver's lap times, but their mean is the same? All right, it means that even though the drivers had the same average lap time, the first driver showed greater variability because the standard deviation was higher. So greater variability in the lap times of the 50 laps. The first driver has lap times that were slower and faster and less clustered near the mean than the second driver lap times. So if you were to see this data on a dot plot or on a histogram or on whatever, you would be able to see that their mean is the same, their average is the same, but the first driver the lap times are going to be spread out more than the second driver. So the second driver would be like a cluster of times around the mean, and the first driver is going to be spread out away from the mean. All right, so that's all we're going to talk about there. The next thing I want you to do is go look at your lesson summary, which is right above this. I want you to read it carefully. I want you to highlight, which you can use the little markup tool in Cami. Highlight anything that you see that's important that we've talked about. Looks like this last little paragraph is pretty important. Anything that looks good, don't just go through highlighting the entire thing. I want you to read it, and I want you maybe make notes or highlight, just kind of like we did up here with these data sets. You know, we highlighted the mean and the standard deviation. We highlighted the data as we discussed it. So just things like that. That will help you retain it more for whenever it's time to take a test or later on in the future when you need to know this information. It will help you. After you finish this, then I need you to go back to Schoology and work on the 13.4 cool down.